Newton had already argued quite effectively, and I don't know of any place where Einstein talks about this. Newton had come up with exactly this debate, and it happened with Leibniz, right? And it happened in the form of this set of letters indirectly between Leibniz and Clarke, Clarke was Newton's representative, the so-called Leibniz-Clarke correspondence, right at the end of Leibniz's life. And it was all about this. It was, is space in itself a thing that exists, that has a structure, or is all there is to space the relative positions of material bodies? And Newton was very clearly on the side of space and time are real entities, and they have a structure that's there independently of whether there's any material at all. And Leibniz, if you know Leibniz didn't like that. I mean, this is this kind of intermediate Leibniz. That is, the deep Leibniz is the monadology. That's just a kind of really crazy view. And then there's this sort of intermediate Leibniz where you're doing what looks more like recognizable physics. But one of Leibniz's ideas is that space and time and motion had to be exposited or understood as always the relative motions of bodies in some sense. There's no absolute motion. We just said for Newton, there's absolute motion. Even if there's only one material body, it can be moving. That debate was really settled in a way by Newton in Principia with the bucket experiment.